Hello, and welcome back, coders. In this episode, we will continue to create our data models. What exactly is a Sudoku puzzle? Well, we need three things. The initial board with some numbers filled in, those are the clues, the complete solution, and the difficulty level. Let's create a class to represent this. We'll call this class SudokuPuzzle, simple and descriptive. First property, initial. This is a list of integers, essentially a 9x9 grid. This represents the starting board that the player sees, with zeros for empty cells and numbers 1 through 9 for the given clues. Next, the solution. Same structure, a 9x9 grid, but this one contains the complete solved puzzle. We'll use this later to check if the player's answer is correct and to provide hints. And finally, difficulty. This is just a string, easy, medium, or hard. We'll use this to display the difficulty level to the player and to filter puzzles when starting a new game. Notice all three properties are marked as final. That's because once we create a puzzle, it never changes. It's immutable. The puzzle itself doesn't change, only the player's current board state changes as they play. Now we add a constructor. We're using named parameters with the required keyword, which means anyone creating a Sudoku puzzle must provide all three values. This prevents bugs where we might forget to include the solution or difficulty. And that's it. We have a clean, simple data model. Now we have our puzzle structure. Next, we need a GameState model to track the player's progress, move history, and all the data that changes as they play. Let's create that now. Now let's create the most important model, GameState.Dart. While SudokuPuzzle represents the puzzle itself, GameState tracks everything that happens while the player is actually playing the game. First, we import our SudokuPuzzle model because we'll need it to create a new GameState from a puzzle. Let's create our GameState class. This will hold all the dynamic data, everything that changes as the player plays. First, current board. This is the player's current progress. The board, as it looks right now, with their entries. Notice this is not final because it changes every time the player enters a number. Next, solution board. We store the solution here so we can validate answers and provide hints. Then, fixed cells. This is a 9x9 grid of booleans that tells us which cells were part of the original puzzle. If it's true, the player can't edit that cell. It's one of the given clues. Now here's an interesting one, notes. This is a 9x9 grid, but each cell contains a set of integers. These are the pencil marks or notes that players use to track possible numbers. A set is perfect here because each number can only appear once. Move history, a list of GameMove objects. Every time the player places or changes a number, we'll record it here. This is what powers our undo feature. We'll create the GameMove class in just a moment. And three more simple properties: the difficulty level, how many hints the player has used, grade for showing stats, and start time so we can calculate how long they've been playing. Standard constructor with all required parameters. Pretty straightforward. Now here's where it gets interesting. We need a way to create a game state from a Sudoku puzzle. Let's use a factory constructor for this. We call it fromPuzzle, very descriptive. This will take a puzzle and initialize a brand new game state. First, we initialize an empty notes grid. 9 rows, each with 9 empty sets. The underscore means we don't care about the index value here. For current board, we copy the initial puzzle. Notice we're using list from. This creates a deep copy so we don't accidentally modify the original puzzle. Same thing for the solution. For fixed cells, we generate a grid where any cell that's not 0 in the initial puzzle is marked as fixed. So if puzzle initial in row 2, column 5 is 7, then fixed cells in row 2, column 5 will be true. Empty notes and empty move history, brand new game. Copy the difficulty, 0 hints used, and capture the current time. And that's our factory constructor. This makes it super easy to start a new game from any puzzle. Now, we need to save and load games. That means converting our game state to JSON and back. Let's add those methods. The toJson method converts our game state into a map that can be saved as JSON. The boards can be saved directly. Lists of integers work fine in JSON. For fixed cells, we convert booleans to integers. True becomes 1, false becomes 0. JSON handles numbers better than booleans in some cases. For notes, we convert each set to a list. JSON doesn't have a set type, so we need lists. Move history calls to JSON on each move. We'll implement that next. And datetime gets converted to an ISO string format. Now the reverse, loading from JSON. Another factory constructor, this time called fromJson. We convert the JSON arrays back to proper Dart list integer. The nested from calls ensure we get the right types. For fixed cells, we convert those 1s and 0s back to booleans. If it's 1, it becomes true, otherwise false. For notes, we convert those lists back to sets. This looks complex, but it's just converting nested structures back to their original types. Move history recreates GameMove objects from JSON, and datetime.parse converts that ISO string back to a datetime. And we're done with GameState. That was a lot, but now we can save and load complete game progress. Now let's create that GameMove class we referenced earlier. This represents a single move the player made. 5 properties: which row and column, what the value was before, what it is now, and what notes were there before. All final because once a move is recorded, it doesn't change. Simple constructor with all required parameters. toJson is straightforward, just convert the set to a list. Let's review what we built. GameState tracks the entire game, the current board, solution, which cells are fixed, player notes, move history, difficulty, hints used, and when they started. We can create one from a puzzle, and we can save and load it as JSON. GameMove tracks individual moves for undo functionality. This is our game's brain, all the data we need to manage a complete Sudoku game. Excellent! Our data models are complete. In the next episode, we will create our puzzle library with easy, medium, and hard puzzles. So if you find this project interesting, please hit that like, subscribe, and notification button. It really helps me to continue making more videos. Thank you for watching, and see you in the next episode. Happy coding!